Data access patterns refer to the various ways in which data can be accessed and retrieved from storage systems, databases, or data sources. Different applications and use cases require different access patterns to efficiently retrieve and manipulate data. Here are some common types of data access patterns. Sequential access. In this pattern, data is accessed in a linear order, one after another. It's efficient for reading large sets of data that are stored sequentially, like log files or data streams. Examples include reading records from a file, processing logs, or streaming data. Random access. Data is accessed directly by specifying an index or key, without needing to read data sequentially. Efficient for retrieving specific pieces of data from large datasets. Examples include key-value stores and database systems. Batch processing. Data is processed in batches, where a group of records is processed together. Common in data warehousing and analytics, where large amounts of data are processed at once to generate insights. Suitable for aggregations, transformations, and reporting. Real-time processing. Data is processed as soon as it arrives, allowing for real-time analysis and decision-making. Common in event-driven systems and applications that require immediate responses to incoming data. Examples include real-time analytics, fraud detection, and monitoring systems. Transactional processing. Data access involves transactions that ensure data consistency and integrity. Common in applications that involve financial transactions, order processing, and data updates. Ensures that multiple operations are either completed together or not at all. Asset properties. Read-heavy. The application's primary workload involves reading data more frequently than writing. Examples include content delivery networks, CDNs, and reporting systems. Write-heavy. The application's primary workload involves writing data more frequently than reading. Examples include logging systems and social media platforms where users generate a lot of content. Search and query. Involves searching for specific data using queries or search terms. Common in applications that require full-text search or complex querying, such as search engines and e-commerce platforms. Caching. Data is stored in a cache to improve access speed and reduce load on the primary data source. Often used to serve frequently accessed data quickly, reducing the need to retrieve it from the original source. Paging and pagination. Data is retrieved in smaller chunks, pages, to improve performance and user experience. Common in web applications to display large datasets in a manageable way. Data streaming. Continuous flow of data is processed and consumed in real time. Used for processing and reacting to data as it arrives, such as in IoT applications or real-time analytics. MapReduce. Data is processed in parallel across multiple nodes, involving a map phase for data preparation and a reduce phase for aggregation. Common in distributed computing frameworks like Hadoop for large-scale data processing. Each data access pattern has its strengths and weaknesses, and the choice of pattern depends on the nature of the application, performance requirements, scalability needs, and the characteristics of the underlying data source.